Valid perfect square. Given a positive integer name, write a function which return true if name is a perfect square as false. Okay, do not use any built-in library function such as square. Okay, so the problem is they will give an integer number and then we need to decide if it is the perfect square or not. If it is for 16, it is perfect square of perfect square, right? Because 4 into 4 is 16, right? 25, for example, 25, 5 into 5 is 25, so 25 is also the perfect square. So the way we can solve is using the brute force method. Like brute force means we will look from the zero, from the 1 to square root of n. For example, if we have if we have 16, we will look for 1. Okay, 1 into 1 is 1. Okay, it's not 16 yet. No. Okay, 2. The 2 into 2 equal 4. What about 3? 3 into 3 equal 9. And then what about 4? 4 into 4 equals 16. So we will start, right? So from 1 till we didn't find the result yet, we will look for the again, right? So the complexity is gonna be order of square root of n, right? Okay, so what about 14? We will look for 1 and then 2, 3, and then when it is 4, we got 16. So 16 is greater than 14, we went, so we were stopped, right? And then we can return no, it is not a perfect number, and then we can return a false value. So but you know, it is time complexity is the order of square root of n, so it looked good, but we can solve in a better way by using binary search. Binary searches, we will have, for example, if it is 16, for example, the same way. Okay, 16, we will look for 1 and then 16 range, and then we will look for the middle one. What is the middle? For example, if the middle is 8, we will look for the 8 into 8. 8 to 8 is 64. It is bigger than the numbers we want, right? So we will look for 1 to 7. We will divide half and half. So the time complexity is gonna be order of log n, right? According to the binary search tree, binary search, right? So let's do this. We will go half, right? So we will need the 2 pointer, left pointer and then right pointer. Right, it's gonna be equal names, right? Okay, so we will loop until left less than right, and then we will look for the mid value, and then left plus right minus left. It is we can use any formula we want, like for example left plus right by 2, right? The way to look for the middle value is we can look for any of them, but to avoid the overflow, for example, if the integer is that if the enums it's the maximum value, like int of max value, so at the time if we plus and plus, we will get overflow, right? The integer value cannot hold the sum, right? So by doing this way, we can avoid the overflow of the problems. Okay, so we got the mid value. So if we got a mid value, we need to multiply mid into mid, right, to compare with our desired values. So if we multiply mid into mid, integer, if for example middle value is, if they are the in maximum value, so in the same way we're gonna get the overflow, right? So that's why I will use long for the product. Okay, and then we will check if temp equal now. That means if it is 16 equals 16, we got 16, 16, return 4. We don't need to do anything, right? True. Alt, or the, if we don't return, we will go down, right? And then temp less than names, we will move the left pointer to the mid +1, right? Else right pointer is gonna move to the mid -1, and then we will loop again, and then if we don't find it yet, we will return false, right? Oh, I am sorry, is there something wrong? Okay, so if less than or equal till equal, right? Okay, so what if we set, I think we can even set from 1, right? Okay, I'm gonna submit this one. Okay, so time execution limit. Okay, so we just accepted we need to convert this one value to the long value, right? Maybe that's why, because we inverted the product, we accept with a long value, but this one's gonna be overflow, and maybe that's why we got that error. Okay, so that's it. Thank you.